So now we're going to talk about the ratio test. The ratio test measures the rate of growth or decline by examining the ratio of a term and its preceding term. So that's what we're looking at in here, right? And if you remember, we talked about geometric series already, and geometric series have a constant ratio, which is always going to be that ratio of a term divided by the term which came before it. And we also want to recall from geometric series was that if that ratio, if a sub n plus 1 over a sub n, the absolute value of that ratio, which we might call absolute value of r, if that was less than 1, we could assume convergence. And so what the ratio test says here is that suppose we have a series, any series, and if we look at as my terms become infinitely large, my infinite term, okay, so as the terms are getting bigger and bigger and bigger and further away from where we started, that ratio, the absolute value of that ratio, we're going to call it this value rho. Okay? And if rho, the absolute value of rho, is less than 1, we can say that it converges absolutely. If rho is greater than 1, we know it would be divergent. And if rho is equal to 1, we cannot draw any conclusions. So just to restate that, our steps when using the ratio test, we're going to always look at the ratio of a term divided by its preceding term in absolute value. And we're going to calculate that number. And it's always going to be a positive number. So, because we have our absolute value bars here. If rho is less than 1, we say absolutely convergent. If rho is greater than 1, we say divergent. And if rho equals 1, we cannot draw a conclusion, inconclusive. When is it useful or effective to use the ratio test? When we have terms of a series containing factorials or involving expressions raised to a power of n. So if you have some number 5 to an n or some sort of n factorial, these situations we generally lean towards the ratio test. So let's do an example here. We need to investigate the convergence of this series from 0 to infinity of 2 to the n power plus 5 divided by 3 to the n power. So in this example, you see we have a number raised to that variable power n. So we're going to apply the ratio test. And we know what the nth term looks like. This is going to be my a sub n. But what does a sub n plus 1 look like? Okay, so a sub n plus 1, the term following that. That would be 2 to the n plus 1 plus 5 over 3 to the n plus 1. So my ratio would be the n plus 1 term, 2 to the n plus 1 plus 5 over 3 to the n plus 1. That needs to be divided by the term which came before it, which is 2 to the n plus 5 over 3 to the n. All right, so we're going to simplify this, and then we're going to look at what happens as n becomes infinitely large, as we apply that limit, n approaching positive infinity. So first thing to do when simplifying this, we're going to copy, change, flip. Remember, division is multiplication by the reciprocal. So this is the absolute value of 2 to the n plus 1 plus 5 over 3 to the n plus 1 times 3 to the n over 2 to the n plus 5. So what happens when I go to simplify this? What happens with 3 to the n over 3 to the n plus 1? Well, that's the same as 3 to the n minus n plus 1, which simplifies to 3 to the negative 1, or 1/3. So this is now equal to 1/3 absolute value, 2 to the n plus 1 plus 5 over 2 to the n plus 5. So looking to simplify this so we can apply our limit to infinity. I don't like this n plus 1 we have as a power. So what I'm going to do is I'm going to take that rational expression. Remember, it's okay to multiply by 1. So I've got 2 to the n plus 1 plus 5 over 2 to the n plus 5. And in this situation, I'm going to multiply by 2 to the negative n over 2 to the negative n. So all I'm doing is multiplying by 1. And I picked that especially because when I multiply in the denominator, that's going to turn to a positive 1. And when I multiply in the numerator, this is just going to become 2. All right? So this simplifies, and we've got 1/3 2 plus 5 times 2 to the negative n over 1 plus 5 times 2 to the negative n. So I'll just do one more algebraic manipulation here. This is 1/3. I've got 2 plus 5 over 2 to the n over 1 plus 5 over 2 to the n. So if we take this, this is my ratio, the absolute value of my ratio of the two terms. If I take all of this and look at, well, what happens? What is the limit as n approaches infinity? Well, if I go and plug infinity in for my n values, 2 to infinity is essentially this entire denominator is infinity. So I've got 5 divided by infinity. And any number divided by infinity we know is going to go to 0. So plugging infinity in and evaluating this, I end up with 1/3 times 2 over 1, which gives us 2/3. So my rho value, rho, is equal to 2/3. And since rho is equal to 2/3, that is less than 1, then we can say it is absolutely convergent. So we know if it's absolutely convergent, it converges. All right? So thus, that series n equals 0 to infinity of 2 to the n plus 5 over 3 to the n converges. It is important for you to note here that that 2/3 is not the sum. It is my rho value, and it is just telling me that this is a convergent series.